All right, thank you so much for joining us today. First day of Dreamforce. I hope you're all having fun. Welcome to our session on deep dive into advanced Apex best practices. How many of you are Salesforce developers here? And how many of you use Apex? There you go. There you go.
You're in the right place. Good. Yeah.
All right. So before we move forward, you would have seen this slide already like 1,000 number of times. I promise you, in next 3 days, you'll see another 1,000 number of times. This is our forward-looking slide. So please do not make any purchasing decisions on anything futuristic that we might present here. Thank you again. You all actually inspire us to innovate better. In fact, a lot of the content here is driven from community posts that you all have put together. So really thank you thank you for pushing us to innovate better. With that, my name is Mohit. I'm a developer advocate here at Salesforce, primarily focused on platform, and I have with me to help me here, and also, I know you all will have tough questions. That's why I have product manager here, Daniel.
Hi, yes, I'm Daniel Ballinger, the product manager for Apex, and happy to take your questions.
All right. With that, what would be our agenda today and what we'll be focusing on? So we only have 45 minutes, so it's always hard choice to actually pick up, okay, what topics are we going to talk? So today we're going to look at some of these items here, like designing asynchronous Apex. We'll talk about, batch Apex, queuables, platform events, how to design them, what are some of the considerations that you'll have to take on our platform when you are thinking of using this, and triggers. How many of you have triggers in your org? Everyone, right? Everyone writes triggers, right? So one of the common questions that we get is, how do we manage trigger recursions? What are some of the best practices around that? So we will demystify that today, like what are some of the best practices that you should adopt there. Concurrency and record locking. How many of you do not hit concurrency limits? You see, everyone, right? Except I think here, we have a gentleman here, writes awesome code. But, we are going to take a look at concurrency, record locking, and then some tips around performance best practices. This is going to be crucial because how many of you have heard of Agentforce and agents? And one aspect of Agentforce will be actions, and these actions are going to be built using Apex as well, apart from other tools that we give you. And I think, to give a better experience with those Agentforce agents, you'll need to consider writing good Apex code with better performant code. And and then we'll take a look at how to deal with large data volumes. Anybody store large data volumes in their orgs? A lot of you, right? So how do you deal with that in Apex? And then debugging best practices as well. A lot of you express like, can you show us like how do you debug? When you have problems. So we're going to have a live demo show you how to use Apex Replay Debugger. So that's our agenda. It's packed, as you can see. We'll kickstart with designing asynchronous Apex here. I want to start with Daniel. I'm a developer, and I always tend to like, when someone talks about like asynchronous jobs, the first thing is like, okay, let me go and go to my lab, bring up my IDE and let's just start writing batch Apex. But today I want to understand like what are some of the considerations that me as a developer should take when building these batch jobs in Salesforce.
Yeah, sure. So batch jobs are an interesting one, and it's often a tool people first reach for when they have an async problem. But it's important to use it in the right context. It is, much like it's named for, a process for working over batches of records, which means a large number of records. It's not the tool that you usually reach for or should reach for if you have one record to process asynchronously. It's not going to give you the right performance for that or the right timing. It's a product, as a product, it doesn't have an SLA, which is an important thing to consider when you're implementing your batch jobs. We will run your batch jobs, but you can't rely on it running within seconds or minutes of you queuing it. So you nearly need to design your batch jobs to consider that and be resilient to timing variations that may happen on the platform as message queues go up and down, need to process more or less batch jobs. And it also depends on how you design your jobs for how they come into the system. So ideally, your batch job should not be firing on, say, like a trigger on a record if you're expecting any sort of high volumes or data loads on that. You don't want to enqueue 50 batch jobs to process a small volume of records at a high speed. It's not going to scale well that way.
All right, yeah. So Daniel, so that I understand, right? So what you're saying is these batch jobs are going to be processed. That means your processes are going to happen. But let's say I have two different batch jobs, right? And let's say, I plan my business process such a way that one job starts at, let's say, 11 a.m. and maybe there's another job that starts at 12 p.m. We don't guarantee that those two processes will happen at the same exact time. And you need to design these batch jobs considering that, instead of like that 11 a.m., we might process it maybe at 12 p.m. And then the job that is there at 12 p.m. can also kickstart at 12 p.m. So you can have two jobs running simultaneously, and maybe you have not thought through the design really clearly. So how about I show some of the code on some basic features that they can implement using some of the features that we have on the platform?
Yeah, a demo would be good because we need to make these considerations for what happens when these jobs start running at the same time.
Yes, so this is a simple batch class. Again, nothing fancy about it. All of your developers know how to write jobs like this. So really what I'm doing here, as you can see, is key here is there is this thing called async apex job, and everybody should know about these objects. So in this object, you can always use a filter on apex class ID and the status field here. So I can always query that, are there any jobs in my system that are happening here, right? And based on that, if, like for example, if, in this case, if the job is happening, maybe, because the job is happening, I might stop the job that was supposed to happen, right? And I might reschedule that at a later stage. So at bare minimum, you should know this, that there is this async apex job, and that will tell you the status of these jobs, and based on that, you can plan your strategy. Again, it all depends on your implementation, so there's no like one method that we can give you, right? Sometimes what I've seen from my experience, Daniel, is what happens is sometimes you have these jobs, and I want to know which job actually processed this record before the next set of job runs. So I was able to tag on all these records, like which job actually did the process by assigning, let's say, a unique ID to a job.
Mm-hmm. Yeah, but the key is we're protecting our jobs from trying to process the same records at the same time, which is just going to cause locking issues or overwrite issues if you're locking them correctly. So we just remove that problem outright by keeping them running one at a time.
Perfect. All right, moving on. What about queuables though? Like, I know you talked about batch apex, which is for heavy volume processing. There's another asynchronous pattern that our developers use, like queuables. What about some of the considerations that we need to make when we are dealing with queuable classes?
So queuables is an interesting one. Again, technically it doesn't have an SLA, so ideally your user shouldn't be sitting there immediately waiting for this asynchronous process to respond. It will respond a lot faster than a batch job, but there's still no guarantee that that will actually happen immediately for them. Queuables are also interesting because they have the potential to fan out or expand the amount of processing that's coming out of one transaction quite rapidly. And so it's important that you consider how you implement your job to get the most performance and throughput from the system. Obviously, if you try and have all your queuable jobs run at once and perform a large amount of processing, it's going to overload the queues and things are going to slow down. So if you can keep those jobs running fast as you can, we'll turn through more of them faster. And then we've also given you controls to help you maximize the amount of processing you're getting out of your jobs. So there's 3 common scenarios. Like the worst possible scenario is you create an infinite chain of queuable jobs that just keep recursively working through and never finishing. To help with that, we've given you a depth control. We've also given you 2 other features, delays. One bad scenario you can do with a queuable job is trying to integrate with an external system and not having that external system ready to respond yet. So you have your queuable job sort of busy wait, which is a pattern we don't really support. But if you do that, it's tying up a whole queuable thread waiting to work. It's much better to use our built-in delay functionality when you enqueue your job. And then finally, we also have a deduplication flag. So if you have triggers or other things that are potentially enqueuing the same job multiple times, you can reduce those redundant jobs and just have one of those queuables run. And did you have a demo for us on transaction finalizers, which is another key part?
Absolutely. So how about we actually go look at a class that I have. Again, I'm using the queuables here. So as one of the things that we see here is one of the common features that we all need to understand is Cubables get these finalizers. So I can have a finalizer class attached to it. And really you can see this is like a retry finalizer here that I'm showing as an example. So the best part about the finalizer is you can actually read and find out exceptions like unhandled exceptions. So in this case I'm not passing anything as a constructor, but imagine you had some failures like unhandled exceptions in your Cubable class. You could easily pass those records that actually got failed as unhandled exceptions through the constructor, and then reprocess them or retry them using the finalizer. And it's one of the features of the platform or the Cubables that I really like it. And again, as Daniel was saying, there are other features here in Cubable that I wanted to show, like for example, depth control. So you can see, when I'm actually invoking these, I can set this maximum Cubable stack depth so that, when you're enqueuing, you're sure of the amount of depth that you want this job to try, So you can set that, and also prevent duplicates like race conditions, right? You don't want duplicate jobs to be happening, so you can assign a duplicate signature now. And hopefully, these features like delays and being able to set the max, stack depth and duplicate signatures along with finalizers give you enough tools to come up with your own pattern. Again, we don't want to promote one pattern here. Our community comes up with a lot of patterns. I just want to show you the the fundamental features that we give you, so that you can use that and design things. Like for example, in this case, it could be recovery mechanisms, or let's say you need some more logging here. You can definitely redesign that with finalizers.
The transaction finalizers are key as well, because sometimes they're the only mechanism you can use to handle a certain type of exception. So if a heap or a CPU limit exception happened, transaction finalizer is the only mechanism you have to actually handle that.
Perfect. Moving on, let's talk about something else here, which is platform events. So you understood batch epochs, you understood Cubables, right? There is this new set of things called platform events. How many of you used some of these events like platform events before? Okay, perfect. So there are key design aspects to understand in platform events. One aspect of platform events is they are processed synchronously on the platform, even though they are invoked asynchronously. That means all the synchronous limits apply. But the best part about these platform events is, unlike triggers where we chunk the number of records into 200 batches, this is little flexible. You can actually configure it. So you can have anywhere between 1 to 2,000 number of platform events. So you can really control based on the processing that you need. So that's the power of platform events. Like it allows you to chunk your processing into like smaller batches if you need to. And then it has like the built-in retry mechanism. It supports parallel processing. So this is another feature that we added in winter release, is being able to parallelly process these records. So let's say you have a large number of transactions to accomplish, you can definitely group them, and then process them parallelly. So that's another feature. One thing to remember though is, platform events, they are based out of this distributed architecture. That means the event delivery is not guaranteed, but you can always implement callback handler to identify the events that did not get published. So how about we take a demo of that and show you some of these in action so that you can actually understand them. So I'm gonna go here and let's open one of the platform events that I have and kick it in. So let's go here, and here's the demo. So really what I'm trying to show here is I have a simple platform event here that I'm publishing. It's called low ink platform event, and you can declaratively create these platform events with fields that you want. What I'm doing here is just going to publish it. So I'm going to go ahead and just sort of execute this. Sometimes it just takes a reload here. So let's just
I think it'd be more realistic if we had low cyan ink. That's what my printer always does. But
yeah, so there you go. It executes. So it executed here, right? So here you can see that we are able to basically publish this event, right? Now what is happening on this event is key. Is you can write on these events triggers, just like you write your regular triggers. So here I'm within this low ink trigger, and this piece of code, it's basically telemetry. So I've built a lightning component that I'll show you. So I've created a telemetry so we can see exactly how this platform event is processing this. But the key here to understand is, as you can see, we can loop over these events, right? And then look at this piece of code here where we can attach the replay ID so that in case I want to reprocess this, let's say there is some failure that is happening while this platform event is running. Let's say a governor limit got exceeded or any Apex unhandled exceptions that you can think of, right? So for example here, right, where I'm collecting all these low ink events which got failed. I've set the resume checkpoint so we can basically resume it at will. And here is that class where I'm doing a little bit of processing. So you can see randomly I'm failing it just to simulate this, that the retry happens. What I'm doing here is I'm actually catching that exception and telling it to retry 2 times before I kind of just ignore these events, right? So if we go look at the telemetry here, that's exactly what it's going to show. So you see we kicked off 100 number of jobs here, right? Sorry, 100 number of records here. But you can see it failed due to one of these errors called invalid custom exception. And you can see that it retried for once and then it retried for twice before it kind of started ignoring. But I could decide what I want to do with it, and that's the power of it. Like for example, with platform event, right, everything gets a replay ID. So let's say this was a code issue in my trigger, right? So what I can do is I can go back, fix that trigger and the issue, and then read that replay ID through the API and replay it back, so all those records will be processed again. So you see the power of this, right? You can reprocess stuff, and that is what platform events, and that's the core differentiator for the platform events is like this ability to retry and ability to control the batch size too. In this case, I didn't have any batch size there, but you could we could easily like count on the number of records, break this into number of other jobs and whatnot, right? So it really helps you to manage governor limits. If you had like heavy thing to process and if it's not within the governor limits of the platform, you can chunk it up and chunk it by the size, and then you can have more number of jobs, right? So almost like horizontally scaling, right? With that, I think let's look at all of these in in comparison, like batch Apex, queuables, platform events. No one-size solution, right?
Yeah, so certainly, no one-size solution. With batch, again, you want to be considering not processing records one at a time, having batches actually work over larger volumes of records, and then making your batch jobs, constructing them in such a way that they're protected in case there's some delay in the processing. They're not so time sensitive. They will get there, but they're designed to run over large series of records in the background.
Awesome. All right, moving on to something synchronous, which is triggers, right? Everybody has triggers, and one of the common problems, and in fact we see it in our metrics here, is like number of recursions that these triggers run into. So Dan, let me ask you this: like, what are some of these ways to prevent these recursions? I read it in forum, somebody says use booleans, somebody says use sets, maps. Like, how do you prevent these recursions from being happening, with triggers?
So yeah, trigger recursion is a tricky one. Like, so most people, they start out, they write their trigger and they process it to like handle one record, and they think that's great. And then they think, oh, hang on, I better stop recursion happening if that, like, my account updates the contact, updates the account. So they maybe put in a boolean to say, don't process this record again. But what they haven't considered is what happens if there's more than 200 records in the transaction, or even more than one. Your trigger will get called multiple times for each batch of 200 records. And so you can't just rely on a single straight boolean to say, don't process this again. So a lot of people will then maybe reach for like a set or a map to say, these are the IDs I've processed. But that then also runs afoul of other issues, such as if you use database with all or none equals false, it is actually going to attempt multiple times to update that record if some of the records in that transaction fail. So you could actually see the same record multiple times. So you need to consider that as well. So it's not an easy problem.
Yeah. So just to repeat, right? So what Dan said here is there are use cases like database.insert or update with this flag all or none. And in fact, when you do data load, this all or none is false by default.
Yeah.
So what happens is, your static booleans or static sets or map doesn't reconsider that sometimes we intentionally want to run more than one processing, right?
Yep.
So that we call it as partial save behavior. Sometimes the platform has to run a couple of number of times, and your static sets or booleans are stopping it from happening. And you know that what that is going to do is cause data inconsistency. So how do we solve that problem, right? So simple, right? So for update triggers, Dan, how do we solve this?
Well, yeah, so you can compare values from trigger old and trigger new, and then rather than relying on a Boolean, you can actually look for changes in the fields you're interested in to say, did the thing I'm triggering on change? Well, yes, my trigger should fire.
Yeah, but if you end up using, like, I know you said trigger.old and trigger.new, but for all of us know that for insert trigger scenario, there is nothing like trigger.old, so there's nothing to compare. So, like for example, this scenario here, right? I'm inserting an account which is creating a task, and let's say a task has a description of a competitor's account name, and I want to create an account record on the insertion of the task record. So you see what is happening. I got account, I inserted task, but then there's a trigger on the task that is actually creating this account again. And again, because I have a trigger to create task, it's all recursing, right? And it's an insert scenario. So how do we solve this? You know? Yeah,
it's a tricky one. You can't use just a single Boolean and just set it to false. You can't use an old map because it doesn't exist.
Then how do we solve that? Right? So how about we show that what is required to solve this kind of tricky problem here, right? So one of the so this one is very clear. It's for update scenario where you can compare trigger.old and trigger.new. But how about we look at this one, right? So this is a very tricky scenario, and in this scenario, there is no other option than using booleans to stop it. Exactly what we said, like you don't use boolean, but you have to use it in this scenario. But here's the catch. The catch is, look, for example, here we have this boolean called false, right? And then we say, if the boolean is true, return this logic or block this from all these things happening, right? And here I go ahead and set it. And it's really tricky to understand, but after your DML, you should reset it back so that we are not stopping anything that we, like Salesforce as a platform, wants to reprocess. So managing your state or resetting your state is the key here. Yeah. It's really tricky to understand because, I always think in terms of procedural programming language, and here I go and I'm like, okay, I have my trigger for 200 set of records, and here I come for very first time and I say, is account insert trigger running to create, right? I set this thing to true, and then it comes here and it inserts this task, and the next thing it comes here is false, so I'm stopping the recursion here, even for the previous scenario. But that's not how things work, because after this insert trigger, the next trigger is going to kick off, and we're going to stop that here by blocking this logic. But once that block happens, it has to go to the next statement, which is this, and then it has to set the false, and then we set it false, so we really unset the static here, and in this case, it'll just be fine. And we actually demoed this in live at TDX, and we have got the session recordings we will share in the resources in our last slide, and you can see we actually go and show this live with examples and running some scenarios. So we didn't want to do it live here because it's going to take the whole session. It's that long a topic, but it's pretty simple. You have to just understand that if you use booleans, you have to reset it, and where you will reset it is on the DML that is actually causing the recursions. So hopefully that was clear around trigger recursions. The next thing that we want to talk about here, Dan, is managing concurrency and record locking. This is also one of the topics that comes up very frequently. So first of all, let's understand like what is record locking and when does it have? When does we lock records here at Salesforce? So first primary cause for them is when you have SKUs. How many of you have had SKUs here? Like, do you have like a parent record where you have more than like 10,000 child records? That is what we call as lookup SKUs. It's an architectural, I would say an architectural gap that you built it into your system, and now it makes it very difficult for Apex. Similarly, we have ownership SKUs, right?
Yeah.
Dan?
So
what
like
is ownership SKUs, Dan?
So much the same with lookup SKUs, except rather than relying on one record being related to another record, you're relying on one user owning a large volume of records. might have it for like a sales inbound pipeline,
Yeah.
where you just default assign everybody to the same user.
Yes.
And that causes issues if you need to make changes to that user's permission model, because now all of a sudden it's impacting a very large volume of records.
Right, right. So what happens in this scenario is, let's say, you are processing child records when you have a SKU, and that processing, because there is large number of records too, and for the data consistency, we will have to lock that parent record for which the child records are under the process. Now what happens is, if you have another process which is trying to update the same parent record that is in the lock state, you'll hit that record locking error. It's pretty simple. And this is what causes the record locking most of the times. So really, I think the best practice here is to write efficient code, keep your transactions under 5 seconds typically. And Salesforce is generally good at avoiding race conditions, but if you want data consistency, you can use for update. Just note that, use it very carefully, because then you are deliberately saying that you are locking this record to avoid conditions, and it can cause more row lock issues. Really, the way I've solved this record locking is something that this issue is actually, you can catch them and retry it. For synchronous transactions, you can just retry it. For asynchronous transactions, you can just add a little bit of delay. For example, if you're using queuables, you can just add a little bit of delay to the process, and that next time when it reprocesses, it will be fine. So it's very easy to solve. And also, Scale Center is one of our tools that we give you that can really help identify which user is causing the lock, which process, which Apex class, which method is causing. In fact, it can tell you which record is, which entity is being locked. So using all that metrics, you know that this is the process, and simply by implementing a retry, it'll fix those issues. Dan, one of the other scenarios which is really hard to understand is, how does this entire record locking sort of works for callouts when you're making a third-party callout?
So yeah, for update's an interesting one. So if in your code you retrieve a record via SOCL and you say, I'm going to put the for update clause on it and say I only want it to come back and I want only myself, this transaction, to be able to update it. If you then make a subsequent call out, we won't actually hold that for update lock for you. It gets dropped implicitly. And then of course you can be surprised that your lock wasn't respected. So you need to design your processes that if you're going to make call outs, you need to do the locking after that call out.
Yeah, and this is a good example that we showed again at TDX, and I just want to run everyone through. So really what we are doing is a simple queuable class here where I have a for update on one of these records, right? Now imagine, right, if this process is also making a call out, and if I had 25 of these queuable calls sort of running together, this number, you would expect the number of employees to increment like sequentially, right? But you will see that because of the log being dropped, this will be easily editable by these processes, and you will see that inconsistent results. Instead of like 25, if I had 25 chain of job, I expect that number of employees will be 25, but it will be some random number, and we proved that during our TDX call. So what is important, as Dan said, is to make sure that you are doing all of your DML operations, carefully and designing the order properly. And
another key part of that demo was the interaction with save points.
Yes.
Is that what you were getting to? Yeah. So yeah, you need to consider, do I have an active save point? That's going to prevent me making a call out. But then if I want to roll back my save point or release it before that call out, that's potentially going to impact the for update lock as well. So yeah, do check out that other presentation. We went into it in a lot more detail about how that interaction works.
Absolutely. The next thing that I'm going to talk about is very close to me, because now everyone is in this agent era where you will be building these agents as well. And as I said, you will be using Apex as well. How do we manage these performance? How do we boost some of the performance? So here are some of the tips that we can give you. So the first thing is using platform cache. How many of you use platform cache? Okay, very few hands, right? So if you have data, right, that you're requerying again and again, it's better to just use platform cache.
Yeah, if that data's static and you're going to get the same result back, put it in the cache.
Yeah, and other area where we have seen performance issues is global describes. So why would someone use global describes in Salesforce, Dan?
So usually it's, I want to know, does this entity exist? What is the shape of the entity? the troubling part is when you basically do a describe global and it says, describe me the state of the entire world. It's quite an expensive operation, and very rarely would anybody need to know the state of absolutely everything. Ideally, when you're asking for the structure of something, you would say, ask specifically for the object you're interested in. And we also have a deferred flag, which says, we won't go and pull a lot of extra metadata unless you actually need it, and makes the whole process a whole lot more efficient.
Perfect. And one of the things is like for security, right? Usually I've seen ISVs using global describes for security, but we have given this user mode data operations. How many of you using that feature, user mode data operations? Wow, it's surprising that not a lot of people are using user mode data operations.
We'll keep promoting it, yep.
Yeah, so use the user mode, because then you don't need these global describes and stuff like that. So make sure that all of your previous code is using these user mode data operations. And we've done presentations on that. You can easily find it in the resources that I'll share. The other thing that I want to call out here is finding like the CPU inefficiencies, like identifying that specific class solves half of the problem here. So again, Apex Guru and Scale Center are your best friend because they can spot these things right now. So do use it. Again, we have Scale Center sessions as well where we'll go deep into it. But just remember this. And the other thing that I want to mention here is sometimes the computation is really heavy and you want to process these records like really fast. And one thing you need to understand is at Salesforce we are multi-tenant. So what multi-tenant means is, we have a shared environment, right? So there's only limited capacity, but sometimes you want, your things to be processed really quickly, and that's where I like, that sometimes you have to identify some of these processes and understand that there are alternatives here. Like for example, Heroku is a great alternative because in Heroku you can do like both vertical scaling and horizontal scaling. So let's say you have a process where you need more CPU so that you can process it really quickly. So you can use Heroku, set it up as an API, and bring easily with external services within the platform. And then these external services are exposed in Apex. So you're just calling that service, and that service is doing the processing with much more capacity and with much more flexibility and the control that you actually need for that process. Again, we do a pretty good job with our platform, but sometimes your processes are like, we want this to be like real quick, and that is where the Heroku comes into the picture. And you have to consider those alternatives as well. And we're going to make it very easier, safe harbor again. We have this Heroku actions coming up. That's going to make this really easy to set this up as a part of the core platform. And the next thing we want to talk about is the LDV, large data volumes. Large data volumes, again, I remember we were, talking about large data volumes in the previous sessions as well, and we didn't have solution. I mean, I'll be honest, like 3 years back, we didn't have any solutions of how do you, handle data at scale. So we have Data Cloud here, and it is really important. I think at this point, it's really important for every architect and developers to understand the capability of Data Cloud and how you can, use both of these platforms together to really solve some of the challenges that you couldn't solve. So one of them is, Dan, very common is sometimes I see like, our developers using Salesforce, like the core platform, the CRM, to store a really high volume engagement data, right? And, we'd like to steer you away from this because the more data you have, like the moment you have like 10 millions of rows and more than that on Salesforce platform, it's gonna be hard. Even if you use batch Apex or all the things, right? It requires more scale, and that's why Data Cloud is best fit for it. And we have built connectors now with Salesforce, so it's easy to just sync that data right there and use features like, for example, calculated insights. Like how many of you do roll-up calculations? Imagine you had like a parent record and you have like more than 50,000 records for one parent, right? You cannot process that in Salesforce in Apex synchronously because you cannot query more than 50,000 rows in a single transaction, right? Have you run into that? Cannot query more than 50,000 rows, cannot do more than 150 DMLs, 100 sockets, right? But Data Cloud, right, has features like, for example, calculated insights. I can create an insight, and that insight will automatically do this thing for me, and then I can easily push that calculated insight within the Salesforce platform. And we could even have features such as core object exists within Salesforce, while that high engagement object exists within that the data cloud, and then you mash up both of them. It works beautifully with these features like enrichments. You can even do triggers on them. You know that you can write platform-based, like flow-based triggers on data cloud objects as well. So something to think about when you are dealing with high volume. The other thing is we did something with Data Cloud and Apex too, right? Can we use Apex with Data Cloud?
Yes, we can with DMOs. So we've added static SOCL support in Apex for querying DMOs from Data Cloud. And that just basically works the way you would expect SOCL to. It gives you binding support. You can use with user mode. There's considerations to make there around how the security model works. It supports object level security at the moment, but not field and record level security. But yeah, it gives you a really simple compile time checked, binding support, most of the things you'd expect in Apex. Doesn't currently support batch. If that's a scenario you need, do please let me know and we can work through that. The other thing I was going to mention, we can also do events in Apex in the same way that Flow can. We can write event triggers in Apex on those entities as well.
Platform event based.
Yes.
Right?
Yep.
Perfect. And the other thing that I want to call out here is, the Data Cloud supports SQL. It supports SOCL, but you might have a nested data structure in there, very complex data structure, and you are writing like SQLs. So you can do SQLs as well there, and we support that in Apex. Like for example, there is a Connect API where you can write that SQL. Go to Data Cloud booth and learn if you're more interested, or check out our documentation. So you can write SQLs and call it out. So when you are working with large data volume, remember that now there is a solution, there's Data Cloud already, and there is like 10,000 credits that we give. Only thing you need to understand is credit system, how it works, how the credits are consumed for these queries. But remember that you have 10,000 credits and every org can turn on the Data Cloud right now. So that's always there. Finally, I wanted to, again, we have 2 more slides, but we want to talk about monitoring best practices. Like for example, Dan, I want to talk about, can you help us understand, like when developers are facing things like unhandled exceptions, what are some of the ways to figure that out?
Yeah, so previously in Apex, say you got an unhandled exception, pretty much the only mechanism you'd have to be informed about that would be an email. Now the emails are interesting because they're ultimately rate limited, and that rate limiting means you may not be aware of the magnitude of how many transactions are failing because of that exception. But more challenging still is that rate limiting is not individual to your org. So if there's another customer on that same instance as you who's incurring a lot of exceptions, you may not see the exception at all. So in the recent release, we've added a free tier of event monitoring. And what that means is you'll be able to pull down a 24-hour generated CSV file which has the complete set of unhandled exceptions for your Apex transactions. And that solves the problems of you won't miss gaps and you will get the complete set.
Yes, absolutely. And this is what I wanted to show here is if you turn on the event monitoring, and again, as Dan said, it's free now for unhandled exception types. So you can turn on these event monitoring settings in your org, and then all you need to do is understand that there is this new thing called Apex unexpected exceptions, or it's called Apex unaccepted exceptions. And here you can go and basically pull down your logs. Like for example, here I can go and click on and download it as CSV here. Like you can see, this is a CSV file that tells me that, I had an exception, the exception that we just created, right? So you can see that. So
and the other nice part is you don't have to try and parse that information out of an email. It's all right there in one place, formatted for you.
So something to remember. The other thing that I want to touch base on is Scale Center, Dan. So Scale Center is, again, I keep repeating, Scale Center is a really powerful tool for you as Apex developer. If you haven't turned on in your org, you're definitely missing out on a lot of these features. So I really wanted to show you, some of the Scale Center features here. So one of the features that we have in Scale Center is being able to do the performance analysis. So, I was talking about this record locking, right? So you see in Scale Center, I can go and say, okay, these are the 4 records. These 4 users were causing me these locks, and then I can look at what processes caused it. Like this Apex class, was causing this entity in a lock state, right? And then I can look at which methods took how many amount of time, to do this processing. And there is a lot more things you can do. Again, I don't want to get into detail because this is a session in itself. I have a session on Scale Center. You can find it on your app, where I'm going to go really deep into this and help you understand like what metrics we calculate, how we calculate, and then what are the details that we show. So something to keep in mind. So these are your monitoring tools, and I think there's a lot more things to do here from a product roadmap perspective, but hopefully you have enough tools in place now to understand these exceptions. And the final thing I want to touch base is error logging and debugging best practices. So Dan, I know error logging is one of the areas where our developers actually have a lot of feedback, like how do you log errors, how do you analyze it? Our community has come up with great solutions, but I was wondering if there is anything in your roadmap.
So there's something in the future roadmap where we're basically looking at expanding traceability and observability in Apex. And we're sort of gathering ideas and scenarios at this stage. So if that is something that you work on, please do get in contact. I would like to know more about what sort of information do you need out? Do you get enough information from the debug logs? What format do you need that information in? If there are other systems you potentially want to integrate it with. Yeah, any feedback around those areas is appreciated, and we can help shape that future feature.
Yes, and please talk to Dan after this presentation. So feel free to share your ideas, your critiques about error logging. I myself, Dan, I would tell you, I would love to have a native Apex error logging framework where I can just log these errors and be confident, things like that. We have third-party solutions today, like our developers implementing, but unfortunately, this is an area that we will focus on. The other thing that I want to talk about is debugging. Now, one thing I want to show you, Dan, in terms of debugging, and I get this a lot from our community, is like, how do you use these Apex Replay Debugger? How many have used Apex Replay Debugger here? Okay, a lot of you, probably might be new. So, are you finding it helpful with using that? Okay, for those of you who haven't used it, let me quickly show you how to use Apex Replay Debugger. Again, it comes with this extension, Salesforce extension pack. So you need that Salesforce extension pack actually to be able to use this debugger. And just to show you, the first thing you do is actually turn on the debug log for Replay Debugger. So you see there is this thing, right? So you turn on that. So you click on that, and then you will see that the things actually run. And it will basically create what we call it as tracing flag through the API. So you can see a whole bunch of commands actually got executed. What it is doing, Dan, right? It's creating those trace flags for this particular user so that we can actually stream the logs into our system. So to show you that, I'm going to take a use case that we came across from our LinkedIn community. So one of the members said, hey, we have a queuable process that is happening, the chainable process, this one. So we have a chainable process that actually enqueues for a number of times, and I want to find out how do I debug this when these 5 jobs kind of execute, right? So we have this chainable queuable jobs. Again, it's doing nothing. It's just having a log. But one thing you will see here, what I'm doing just for my convenience so that I can find them in the logs, is I know exactly which job is actually happening is by using something called as request.current. Dan, what is it? What is this request?
That's the request. Oh, so that's the context of your request. So yeah, as you can pull the quiddity from it, which is the type of the request, or you can pull the request ID.
Right? So now what I'm doing is when I'm using this chainable QO, I'm passing that quiddity into my method so that I have something which is trackable. I have that unique ID associated, and then I have this number that is actually getting incremented. So here, right, if you see for the next job, I increment the execution count. So I can identify that, okay, this was my first job, this was my second, this was my third in my logging, right? So why don't we go ahead and execute this? And again, it has the tooling issues a couple of times. Sometimes you just do a couple of times and then it executes. Sometimes I just have to reload this. So bear with me for a sec where we just reload our developer window, and then we should be all set. So there we go. We have our extensions loading. So one of the things we did, Dan, was to make these extensions faster now. As you can see, just instantaneously loaded. And there you go, we executed it. Now, while it's executing, right, I can stream logs now on my local. So the way I do that is Command-Shift-P again, sfdx, and say get Apex debug logs. So now there are no debug logs because I think it's still happening. The execution is happening.
But yeah, if it was running, you would be able to step through the execution.
But let's get. I think it's gonna take some time probably.
I think we're about at time, so we might have to just pretend it worked.
Yeah.
Ta-da! Yeah.
Like live demos, right? Like those cooking shows.
Yeah.
I'm gonna try once more, see if the logs come up.
You're welcome to come by like the Apex booth, and we can work through something like that with you if you're interested in seeing it.
Come to our Apex booth where we can, show you some of these. But really, the idea is, once you have the logs, like for example, I might probably pull up one of the logs that I might have here. So here we have some logs like this, and then once you have the log, all you do is like left click on them, and then just launch your replay debugger with that. You see? So now I can go ahead here, like for example, let's say this log was for a specific chainable class. So I could just go here and click on here, and then we could just, trace through it. Like you can see, this is a log for the finalizer. So you can see that in the system debug. And if we actually go and look at this here, you will see the variables like pointing out. Like you see, you're able to get the job ID and the results, and you can see these variables right there.
Yep. Cool.
So hopefully this was really useful. And again, this is the slide for the resources here. So do take a screenshot of this slide. And we have a lot of resources here for a lot of things that we cover. We'll also share our slides today, so you don't have to find them. And also, we want to thank you. And we'll be here if you have any questions on anything here.
Thank you.
Thank you. And remember to share your feedback.